Hello guys, welcome once more to another video on our YouTube channel. My voice is not really the best, so you have to pay keen attention to the explanations I'm going to be giving subsequently. So in this video, we are going to be solving a Japanese advanced mathematics examination question from the topic integral calculus. So the question reads, we want to show that Alright, so we want to show that the integral from 0 to 1 of the square root of 1 minus x to the power 4 dx is between pylon 4 and 2 root 2 divided by 3. Now, the first part of the equation is saying we need to use the substitution x equal to sine t. So first of all, show that pylon 4 is less than the integral. Then later, we use the fact that if f and g are continuous functions on the interval 0 to 1, then the integral from 0 to 1 of f of x times g of x all squared is less than the integral from 0 to 1 of f of x all squared times the integral from 0 to 1 of g of x all squared. Then using this notion, we have to show that the integral is now less than 2 root 2 divided by 3. So pay keen attention, like I said, because my voice is not really the best. Alright, so we are going to begin with the first part of this proof, and before we begin with that, I want us to first of all note that 1 minus x to the power 4 is the same as 1 minus x squared all squared, and 1 is the same as 1 squared. So if I'm taking 1 squared minus x squared all squared, it's like I'm doing difference of two squares where the squares are 1 and x squared. So by the definition, we are going to have 1 minus x squared times 1 plus x squared. Now, from the laws of indices, the square root of 1 minus x squared times 1 plus x squared is the same as the square root of 1 minus x squared times the square root of 1 plus x squared. Now let's begin with the first part of this question. I just brought this notion because we are going to use it in the second part. So in the first part of this question, we have to use this substitution to show this. But anyways, before using this substitution, I would like us to first of all introduce the inequality sign. So if I take any value of x in the interval 0 to 1, that is my interval of integration, then x to the power 4 will always be less than x to the power 2. Okay, if you take, for example, take x to be 0.5, that is just an example. X equal to 0.5, 0.5 to the power 4 will be less than 0.5 squared. You can try. So any value of x between 0 and 1, x to the power 4 will always be less than x raised to the power 2. Okay, so from there, if I multiply both sides by a negative sign, then the inequality sign is going to reverse because I'm multiplying by a negative sign. So multiplying, we are going to have negative x to the power 4 greater than negative x squared. Add 1 to both sides of the equation, then both sides of the equation are all positive, and if I'm introducing the square root on both sides, then the inequality sign is going to remain intact because the function square root of x is an increasing function in its domain. So if I take the square root on both sides, I'm going to have the square root of 1 minus x to the power 4 greater than the square root of 1 minus x squared. Okay, now I can now integrate both sides since both functions on the left and right are continuous on the given interval and also defined on the given interval. So if we integrate both sides, we are going to have that the integral from 0 to 1 of the square root of 1 minus x to the power 4 will be greater than the integral from 0 to 1 of the square root of 1 minus x squared. Now we are going to use this substitution to determine the integral on the right hand side. So if I let x to be equal to sine t, I will differentiate both sides. I will have the x is equal to cos t dt. Now when x is equal to 0, sine t is 0, so t is sine inverse of 0, which is 0. And when x is equal to 1, sine t will be equal to 1 and t will be sine inverse of 1, which is pi divided by 2 or 90 degrees. So this integral on the right hand side will just be equal to the integral from 0 to pylon 2 of the square root of 1 minus sine squared t, because x was sine t, then our dx has given cos t dt. Now 1 minus sine squared t is the same as cos squared t by the identity. So we are going to have the integral on the right hand side here to be equal to the integral from 0 to pi ln 2 of the square root of cos squared t times cos t dt. Alright, so having that the integral is the same as this integral, you realize that we have to remove this square root from here. But by definition, the square root of cos squared t is the absolute value of cos t. But in the interval 0 to pi ln 2, the cosine function is positive. Therefore, we can just replace the absolute value of cos t with cos t itself. If we were in an interval where the cosine function is negative, then we are going to replace the absolute value with negative cos t. But since in the interval 0 to pi ln 2, the cosine function is above the t-axis, it therefore means that the square root of cos squared t will just be equal to cos t. So if I replace this with cos t, it's going to multiply with this cos t to give us cos squared t. Now, how do I integrate cos squared t? I need to use the definition that cos 2t is 2 cos squared t minus 1. So if I make cos squared t the subject, I'm going to have cos squared t to be equal to cos 2t plus 1 divided by 2. It therefore means that my integral will be equal to my half, because there is a divided by 2, times the integral from 0 to pi ln 2 of cos 2t plus 1 dt. Alright, how then do I integrate cos 2t? So if I integrate cos 2t standardly, I'm going to have half sine 2t. Then when I integrate 1, I get t from 0 to pi ln 2. If I replace 0 as the lower bound, everything is going to give me 0. If I replace pi ln 2 for t here, I will have 2 times pi ln 2 is pi. Sine of pi is 0. Now I replace here with pi ln 2. So at the end of the day, I'm going to have half times pi ln 2. Okay, so half times pi ln 2 is basically going to give us pi ln 4. So at the end of the day, we can conclude that the right hand side here is equal to pi ln 4. So the integral on the left hand side is greater than pi ln 4. So if the integral on the left hand side is greater than pi ln 4, it means that pi ln 4 is less than that integral. And with that conclusion, we have proven the first part of the equation. Alright, now in the second part of the equation, we have to use the Cauchy-Squash inequality. Now it says that the integral from 0 to 1 of f of x times g of x dx all squared is less than the integral from 0 to 1 of f of x all squared dx times the integral from 0 to 1 of g of x all squared dx, provided f and g are continuous on the interval 0 to 1. We are going to use this property to prove this. Alright, at the beginning of this video, I told you guys that we are going to use this, right? So the square root of 1 minus x to the power 4 is equal to the square root of 1 minus x squared times the square root of 1 plus x squared. This means that the integral of the left hand side is the same as the integral of the product of these two functions. Alright, now you realize that if I now apply the inequality, the property above, then if I integrate this function, if I integrate everything here all squared, this is like my f and this is my g. So if I integrate this square, is going to be less than or equal to the integral of f of x all squared. The square root of 1 minus x squared is my f of x, and then the square root of 1 plus x squared is my g of x. So applying this property, then this is going to hold. So it means that this this integrand here is just the same as the square root of 1 minus x to the power 4. We saw it initially, but now we have to square that integral. So it's going to be less than or equal to this. If we square the square root of 1 minus x squared, we are going to have 1 minus x squared because it is positive in this interval, and same thing happens to the square root of 1 plus x squared all squared. It's going to give us 1 plus x squared since it is positive in every interval even. So if I integrate 1 minus x squared, I'm going to have x minus x cubed on 3, right? And if I integrate 1 plus x squared, I will have x plus x cubed on 3. Now I need to integrate, then I indicate my bounds. So this first part here, I'm going to have 1 minus 1 divided by 3, which will give me 1 minus 1 on 3 is 2 on 3, and this second part is 1 plus 1 on 3 is 4 on 3. It therefore means that the integral on the left hand side will be less than or equal to 2 on 3 times 4 on 3. But 2 on 3 times 4 on 3 is the same as 8 divided by 9. Okay, so having that the integral from 0 to 1 of the square root of 1 minus x to the power 4 dx all squared is less than or equal to 8 over 9, we can take the square root on both sides, and since this integral here is positive, then we just take the positive square root. It means that we are going to have this integral here to be less than the square root of 8 divided by 9. Now the square root of 8 is the same as 2 times the square root of 2, and then the square root of 9 is equal to 3. So we have proven that this is true. Now we can now conclude by saying that this and this means that Alright, thank you guys for watching, and see you in the next video. If you love the video, make sure you like the video, you share with your friends, and you subscribe to the channel.